Today I discuss about a new project regarding to the PhD scholars. How the PhD scholars mainly focus on the reference papers and how they are going to create a new model by seeing some references. Suppose if you take this paper as a reference, improved fault ride through capability in DFIC based wind turbines using dynamic voltage restorer with combined feed forward and feedback controlling loop. So I am taking this paper as a reference one to create a new project, and I am using here DFIC rotor side converters and grid side controllers, and then in between these VL and VG, I am designing DVR dynamic voltage restorer to inject the voltage, whatever the voltage will be lagged by the grid terminal. Okay, so how we gonna perform that operation? I will tell you in design clearly. And the control diagram of this one will be follow the similar same design. So how PhD scholars can design a new model? Suppose if you take this paper as a reference one, okay, this one is considered as a reference one. We need to create a new model. Okay. So now I am going to create a new model regarding to that one. I'm just running the model. Why? Because it will take some time. That's why. Okay. So my model is IEEE 33 bus. Okay. This one is the IEEE 33 bus. I'm considering IEEE 33 bus. This one is the IEEE 33 bus. So it having nearly 32 nodes. Okay. 32 nodes it having. At node, each node having different voltages and different current parameters. So I'm considering IEEE 33 bus at the bus 17 terminal. Okay. At the but 17th terminal, that means here, but 17th terminal, I am creating fault. That means at bus 17 terminal, I am creating fault by use of this block. Okay, by adding the fault block, I am creating a fault across the 17th bus. Okay, so suppose if you create any fault across the 17th bus, this model is already run. Okay, suppose if you create any fault across here, the fault here I am taken two, three line to ground fault. I open it here, three line to ground fault. Okay. In the time interval of 0.2 to 0.3. So I am creating a fault here. The dynamic voltage restorer is going to stabilize this fault. How the DVR can stabilize this fault, I will show you here clearly. And this one is integrated with that means by this design, you can easily say that wind is integrated with the distribution IEEE 33 network, okay, through the DVR. This is the new concept. So this concept is totally different from the reference one. So in this model, I am creating a fault at the 17th bus. Whatever the sending end voltage here. Take a look here. This one is the sending end voltage. At the interval of 0.2 to 0.3, I am having zero voltage or short time interruption. Okay, short time interruption. How I need to reduce that short time interruption means with the help of the DVR. This is the DVR control strategy, overall control strategy. These are the overall DVR control strategy. So by using DVR, DVR can inject the voltage to stabilize the voltage. This is the stabilization of the voltage. Okay. In the same manner, you can use uh, you can use single single line to ground or any type of the fault. You can analyze any type of the fault. Okay. So in the time period of 0.2 to 0.3, we are placing single phase to ground fault. At that time, what is the terminal side voltages when compared to this one to this one? Without without DVR. Okay, we need to find out, first of all, we need to see without DVR. Then only you can have the idea. Single line to ground fault without DVR. This model. Okay. DVR, before DVR means DVR we don't connect in this model. Okay. I'm running this model without connecting any DVR. So in these terminals, at these particular terminals, I didn't connect any DVR in it. Okay. After the model, I will show you the results. It will take some time to run the model. So here I am using 9 megawatts wind farm. Inside the wind farm, we are having rotor side and grid side controller as it is in the reference model. This is the reference model that I am taken by this reference model. In this reference model also, they are taking rotor side and grid side converters. Similar in a similar way, we are also consider these are the grid side converter and rotor side converter. So in these converters, we having IGBT anti-vibration of diode. In order to switch off this switch on and switch off of these two thyristors, I mean three-leg thyristors, we require pulse generation. That pulse generation is under the control of the wind turbine control. And here we having uh, synchronization, reference frame theory, in order to get the DQ form and then DQ form to control strategy, we are using low pass filters. Here, this is the low pass filter, and then we are using ABC to DQ transformation and DQ to ABC transformation to stabilize the parameters, whatever the injecting parameters we require at the rotor side and the grid side. It depends upon the mode of the operation. Okay. It totally depends upon the mode of the operation, not and single line parameter. Okay, it depends upon the so many parameters. So this is the overall design, and whatever the terminal voltage here is 575 voltage only. In order to step up the voltage at this terminal, I am having 25 kilowatts. Okay, 25 kV bus it is. So I need to maintain 25 kV by the help of the transformer. So here I am at these wind farms terminal voltage will be 575 only. I need to increase that voltage 575 to 225 kilowatts. I am using this step-up transformer. And before the DVR, I mean without using any DVR here, the waveform, just observe the waveform in between the range of zero point 0.2 to zero point 0.3 from here to here. So this is the major problem. Any fault occurrence time period, the waveform cannot generate a per unit magnitude. Okay, it lacks some voltage. So that lax voltage can observe here carefully in this particular time period 0.2 to 0.3. So by using DVR, you can mitigate the voltage fault. Okay. So the waveform will be improved like this manner. But here also we having DC voltage oscillations in the period of 0.2 to 0.3. For this purpose, okay, in order to stabilize these oscillations of the DC capacitor, I am using PSO algorithm based PI controller. Okay, PI tuning controller. PSO algorithm is the particle swarm optimization. What is the particle swarm optimization major role means? To get the KP and KI values. How we are going to get the KP and KI values means we are proposing particle swarm optimization code here. We need to tune the parameters. This is the tuning parameters. How we are going to relate combine with the DBR PSO algorithm means I will show you here. Here I didn't mention any KP and KI values here. Instead of KP and KI, I am just mentioning KK1, KK2 like this way. So KK1 means KP value and KK2 means KI value. Okay, this is the reference I taken. Suppose if you run the particle swarm optimization before running the, I mean I already run this model. So we get the waveform like this way. Okay, again I show you. the value of the KP value, that this magnitude totally depends upon the KK values. Okay, I will show you here. This KK value right now, it having 0.8397 and 1.9417. This value will be changed automatically while we are tuning the PSO. Suppose if I again run the model, suppose if I again run the model, values of the KP and KA values again change. Okay, 8.30971. Okay, suppose if this takes depends upon the number of iterations. Okay, number of iterations it takes. I am just mentioning one iteration here. For every one iteration, the value of the KP and KA values will be varied. That is definitely varied. Okay, how means I will show you. Now you here, the value of KP and KA values will be 0.8397, 1.94. Okay. In a similar manner, I am just run the model again. So again, I am continuing the one. So it's directly interlinked with the that's algorithm. So here we don't mention any KK values here inside the PI controller. The PI controller KK values will be depends upon the PSO optimized values. Okay. PSO optimized values can be obtained here. That is the advantage of the proposed method. So in order to stabilize these oscillations, we are using a PSO algorithm. So when we are using PSO algorithm, we can get the stabilized VDC voltage at the output side of the PSO. Okay. So this is the overall project regarding to the PhD scholars. Totally, the concept will be different. Okay. By taking reference, we don't having any IEEE 33 bus or else optimization technique doesn't have it at all. Okay. So I am including in this model. In between the grid side and the wind farm, I am creating IEEE 33 bus at one bus terminal. I am integrate this model to that terminal. At the 17th terminal, I am connecting. Okay. And then by the use of the DVR, I can eliminate any type of the fault by injecting the voltage with the help of the DVR itself. Okay. So this is the advantages of the proposed method. Okay. So you can change any optimization technique here. Not only this one, you can change any optimization technique and any case study. You can take single line to ground, double line to ground, triple line to ground. It depends upon your operation. Okay. It's totally depend upon the your operation. Single line to ground, like this way. So we just need to analyze the concept. Okay. We just need to analyze the concept. Then only we can design any type of the model. Okay. This is the overall design of the proposed method. Thanks for watching this video.